Ever since people started thinking about the structure of the universe, they have sought to plumb its depths. But it took an American astronomer to solve the puzzle concerning its limits, if any. Edwin Powell Hubble came at the end of a long line of scientists, some of whom paid with their lives for their curiosity. In 1600, the Holy Inquisition sentenced Giordano Bruno to death, among other things because he had declared the universe to be without limit and home to an infinite number of worlds. 87 years later, Isaac Newton provided theoretical support for the worldview of Nicholas Copernicus, according to whom the sun and not the earth was at the center of all things. In evidence, Newton pointed to the attractive force of the sun, which keeps the planets in their orbits. In so doing, he shook the view taken by the Church to its foundations. But in other ways, he provided the Church with intellectual support. Newton had observed that many of the so-called fixed stars did in fact move. According to his laws of motion, however, everything would have to be in motion, including heavenly bodies still unseen. Consequently, the universe could not have any limits. This explanation by Newton now seemed to go down well in Rome. After all, it accorded with the idea that God had created the universe in his own image. If God was eternal, then so must the universe be. But how did the universe come about in the first place? And why are the stars so far apart when gravity should be pulling them together? Newton did not have the instruments to answer these questions, but in the next 250 years, great progress was made. Using a huge telescope he had built himself, William Herschel discovered the planet Uranus in 1785. While observing the heavens, Herschel also kept coming across bright points surrounded by a sort of fuzz. At first he thought they were stars surrounded by clouds of gas and dust. In 1845, the Irish astronomer William Parsons, the Earl of Rosse, completed his reflecting telescope, which he called Leviathan. Weighing 10 tons, it was the most powerful telescope of its day. With it, Rosse recognized for the first time that many of these nebulae, as they were called, were spiral in form. He did not know that they were other galaxies. His drawing is amazingly detailed, as can be seen by comparing it with a photograph. But while more and more spiral nebulae were discovered, there was still no model to explain what they actually were. This man was to provide the answer. Edwin Powell Hubble was born in Marshfield, Missouri, on the 20th of November 1889, the son of an insurance salesman. At an early stage, he developed a keen interest in astronomy, and Jules Verne's From the Earth to the Moon was one of his favorite stories. His grandfather had built a telescope for himself, and young Edwin spent many a night using it to observe the heavens. His father's business brought the family to Wheaton, a suburb of Chicago. Edwin was allowed to spend the night of the 23rd of June 1899 with his friend Sam in the open air to watch an eclipse of the moon. A magnificent spectacle for the two boys. Because of his good grades at school, Edwin won a scholarship to the University of Chicago, where he studied mathematics and astronomy, besides excelling in college sport. But although his passion was astronomy, he followed his father's wishes, and in 1910 went to England to study law at Oxford. He was neither particularly interested nor particularly successful. 3 years later, he returned and continued his astronomy studies at the Yerkes Observatory in Chicago in 1914. In his doctoral dissertation, Hubble hypothesized that the spiral nebulae were independent galaxies, far beyond our own Milky Way. But in order to prove this, he had somehow to measure their distance. For this purpose, astronomers used a class of stars whose brightness varies periodically, known as Cepheid variables. They have proved a useful astronomical measuring rod. To track down some of these Cepheid variables, Hubble went in 1919 to the Hale Observatory on Mount Wilson near Pasadena, where the world's largest telescope had been brought into operation the year before. A reflector, its mirror was 100 inches or 254 centimeters in diameter. Hubble devoted his attention at first to the Andromeda Nebula, the only galaxy visible with the naked eye from the northern hemisphere. He hoped to find Cepheid variables there. And indeed, after years of intensive observation, he found some in the middle of the Andromeda galaxy. He captured the result on photographic plates. With the aid of the Cepheids, he now succeeded in determining the distance of the Andromeda Nebula from the Earth, a good 800,000 light-years. This enormous distance is about 8 times the diameter of the Milky Way, so the Andromeda Nebula cannot possibly be part of our home galaxy. Although we now know that the Andromeda Nebula is in fact 3 times more distant still, 2.4 million light-years, Hubble had already proved that there were galaxies beyond our own Milky Way. Once it was clear that there must be independent galaxies, Hubble and his assistant Milton Humason set about analyzing their spectra. The lines in a spectrum are what make it unique. They provide astrophysicists with a kind of optical fingerprint, which supplies various pieces of information. Among them, the chemical composition of the source, in this case, the galaxies. The two astronomers noticed that the lines were shifted towards the red end of the spectrum, a sign that the galaxies were moving away from the Earth. This red shift derives from the fact that the light is a wave. Visible light ranges from red, with a wavelength of about 700 nanometers, to violet with a wavelength of 390 nanometers. Waves at the red end are longer. When a cosmic object, a galaxy for example, is receding from the Earth, the waves are stretched. In other words, its spectrum is shifted towards the red end. An approaching body would display a corresponding blue shift. Its waves would be squashed. This phenomenon, known as the Doppler effect, is also observable with sound. It is named after the Austrian physicist Christian Doppler, who noticed that a locomotive steam whistle sounds higher when it is approaching and lower when it's receding. The pitch changes because the sound waves and the sound source are moving. If the source is approaching, the waves are squashed, and the shorter waves sound higher. If the train is moving away from us, the waves are stretched, and longer waves sound lower. If this logic is applied to the galaxies, a redshift, in other words a lengthening of the light waves, means that the galaxy must be receding. Most of the galaxies investigated by Hubble were in fact redshifted, and the more distant they were, the more pronounced the red shift. This means that the most distant galaxies are receding the fastest. This association between distance and velocity has gone down in history as the Hubble effect. It proves that the universe is expanding and that the galaxies are drifting apart, like points on a rubber band when it is stretched. Hubble was even able to back up his discovery with a mathematical formula known as Hubble's law. It states that the velocity of recession, in other words the speed at which the galaxies are moving apart, increases in proportion to the distance between them. Hubble's discovery supports the theory of the Big Bang, the idea that the universe did actually have an origin, a theory in accordance with the creation image of the Christian Church. The Vatican Observatory at Castel Gandolfo was the workplace of the Belgian Jesuit priest Georges Lemaitre, a respected astronomer and an ardent advocate of the Big Bang theory, long before it was given this name. According to Lemaitre, the universe emerged from a primordial atom created by God. He was happy with the idea that the universe was expanding. The astronomer priest sought support for his thesis from one of the most respected scientists of his day, Albert Einstein. However, Einstein favored the steady-state model, a universe with no beginning. When Einstein visited Hubble on Mount Wilson in January 1931, Lemaitre was also present. After they had presented their views to Einstein, he admitted that he had been wrong. But there were other scientists who opposed the Big Bang theory. Foremost among them, the British astronomer Sir Fred Hoyle. Hoyle demanded proof of the Big Bang and wanted at least to see its leftovers. "Let's see the fossil record of this Big Bang," he joked. In 1948, the American physicists George Gamow, Hans Bethe and Ralph Uffer published an article in which they described what this fossil would have to look like. Residual heat in space, a kind of background radiation. They assumed that the Big Bang would have generated an enormous amount of heat. True, the universe had had more than 13 billion years to cool down, but even so, a minimal background radiation was to be expected, just above the absolute zero of minus 273 degrees Celsius. In the mid-1960s, the Bell Telephone Company was carrying out tests in connection with satellite broadcasting. In the process, engineers Arno Penzias and Robert Wilson detected a constant background signal. In order to identify this noise, they calculated the temperature of its source and found it was comparable to that of liquid helium, which is within 2 degrees of absolute zero. The temperature of the radiation they had noticed was just above that of liquid helium, in other words, also close to absolute zero. So Penzias and Wilson had unknowingly discovered the predicted cosmic background radiation, which underpinned the Big Bang theory. For this epoch-making discovery, they were awarded the 1978 Nobel Prize for Physics. Technological progress soon provided more evidence for the Big Bang. In 1992, the satellite Cosmic Background Explorer, or COBE for short, detected oscillations in the temperature of the background radiation. The COBE chart shows the universe at the age of about 300,000 years. The blue areas represent regions with a lot of matter, the red areas with not so much. To obtain new data about the universe, for the past decade, astronomers have been using the space telescope named after Edwin Powell Hubble. In March 2004, it took the most distant photograph ever, and this also means it shows the oldest objects. Some of the galaxies discovered must have been created a good 13.3 billion years ago. Today, most scientists believe that the universe has always been expanding and will go on doing so. The basis for this view was provided by Edwin Powell Hubble in long nights of intensive observation of the heavens.